Okay, so this is a little help with the first exercise of chapter 12. So it's 12a, question 1 and question 2. So as you can see, in order to answer the first part of question 1, you are literally, it says in the hint to put a ruler and then do it by eye, but you know, I've printed it off again. You could sketch it again, then just draw the line. So you meant to estimate the gradient of the curve at particular points. So first of all, this one is a point where x coordinate is -1. So you're going to look at this point on the curve and you're drawing the tangent. So remember from last year, the gradient of that particular point on the curve is going to be the same as the gradient of the tangent, which is the line that touches the curve at that point. And then you just draw the triangle. So there is this line over here. There you go. Okay. And if I pick that point as one of the points on that line and maybe this point over here, so you could see that the gradient is going to be negative, so it's going to be minus, and the difference in y over the difference in x, so this is 1 to 2 up over 0.5, so over half, so that's going to be 2 over 0.5, the gradient, which is -4. It doesn't, you know, if it's something close to -4, round it to -4, okay? The second line is the line at the point that you draw to the curve at the point where x is equal to 0. So it's there, so it's that second line that I've drawn over here. So I've actually drawn a triangle from this point on the line, which is at -2. Well, it's not quite, it is actually 4, -2, 4. And then over here, that's a little bit like -0.5 and 1. So if you think about it, going up, it's 3, going across from -2 to -0.5, it's 1.5, but the gradient is negative. So when x equals to 0, the gradient is going to be negative, and it's 3 divided by 1.5. There you go. So that's going to be -2. There you go. Now at that point, that's easy. I don't need to even think about it. If you draw the line that touches the curve at the bottom, it's going to be a flat line. The gradient of the flat line is 0. And you can carry on this one here. If you think about it, that curve is exactly the same on both sides. So at that point, it's going to be the same as on this. And you can confirm it by actually maybe picking those 2 points. You can see that 0 up to 3, that's 3 up, going across from 2 to 3.5, that's 1.5 up. So it's 3 divided by 1.5. So it's positive. So at x equals 2, the gradient is going to be the same as the gradient of this line, which is a tangent, and that's going to be 3 divided by 1.5, which is 2. So you've got -2, 0, 2, and that you can try for yourself. The next one should be 4 as well, because they're quite, you know, symmetrical. It's the same point here as there, but this is the negative gradient and this is the positive gradient. And it says to write a hypothesis about the gradient of the curve at the point where x is equal to p. So if you notice that if you do indeed work it out as 4, you could see that it follows a pattern. They go up every 2. So it's going to be connected to 2 times tables. Okay, so think about it. When x is equal to p, this is going to be well, let's work out the rule. Okay, so the pattern is 0, 2, 4. Okay, so they go up in 2s. There you go. So we'll work out what it is at p. So to get from this one to this one, okay, so it's going to be 2 times table, which is 2 times p, and then, but you need to go back. If you go back you got a -2, so it's -2. That's the rule. So it's like a linear sequences from GCSEs. So it's going to be 2p minus 2. There you go. But obviously you've learned how to differentiate it, and indeed it's going to be 2x minus 2. So when x is equal to p, it will be 2p minus 2 because you will substitute p into it. Now, to test your hypotheses by estimating the gradient of the graph at the point 1.5 minus 0.75. So using the hypotheses, we're going to put x equals 1.5 into this. So it's 2 times 1.5 minus 2. So it's 2 times 1.5, which is 3, minus 2. The gradient must be equal to 1. Well, let's check by actually now estimating it from the graph. So if you go to one point with the x-coordinate 1.5, so it's over here. If I draw the line at that point, probably not very perfect, but let's just pick some 2 good points. So at let's maybe let's actually go for this one here, and maybe this one at 3. Okay. Oh, you can go even further up to 4. Why not? There you go. So you've got this triangle now. We need to find the size of this triangle. Okay. So this is going to be from 1.5 up to 4. That's going to be 2.5. And this here is about minus 0.8 all the way up to about 1.2. So that takes me about 2. Okay, so my, because my line is not going to be perfect, but using this triangle over here, you could say 2 divided by 2.5. So using the graph, it's going to be 2 over 2.5. So that's going to be actually 0.8 if you use the calculator. So, pretty close to 1, I would say. So that works. Okay, so let's have a look at question 2. So it was part B that caused problems. So in part B, you could see it says use a ruler to estimate the gradient of the curve at the point A. So what they mean is try to draw a tangent to that curve at that point. And that will be used to find the value of the gradient of that curve, because this line has got a negative gradient, it's negative steepness, and so does this curve, and that particular point, it's exactly the same. So all you need to do is find the gradient of that line. So I'm just going to use this point because it's 0.2, and once they go up to 1, 2, 3, 4, 5, so this is from 1. Okay, I'm going to estimate this value. Okay, so if I pick this point, you need to be really careful with the scale. The x-coordinate is 0.2, but you can actually work out the y-coordinate by looking at what is each division worth here. So if you look at there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions between 0 and 0.4. That means one division is worth a tenth of that, so 0.04. Okay, so that means this point has to have 1.0, one lot of 0.04 and another 0.0, so 1.08. And let's pick point A, which we already know the coordinates are 0.6 and 0.8. So this time you could see you could actually use the y minus y1 and over x minus x1 maybe method. We find it easier, but you can just count squares. So the difference in y is 1.08 minus 0.8, and the difference in x is 0.2 minus 0.6. So altogether this will give me 0.2 0.28, shush it, divided by minus 0.4. So let me just find the calculator. That gives me the gradient of 0.28 divided by minus 0.4. That's minus 0.7. There you go. So that will be my estimate of the gradient at point A. Okay. And then when it says to find the gradient of the line segments AD, so then you need to draw the line from A to D, like that, obviously using a ruler. And then you've got to, well, you could use the same method as here. So for AD, point D will have the coordinate X as 1, 2, 3, 4, 5. There's 10 divisions. Again, it's the same scale, so it's going to be 1, 2, actually it might be halfway through, so that's not 0.9. And then to find the y coordinate, we can just substitute it into this. So it's 1 minus 0.9 squared, and then we'll square root it. So that gives me root 19 over 10, and you can get it as a decimal. So the difference in y here is going to be 0.8 minus this root 19 over 10. And then the difference in x is 0.6 minus 0.9. So let's just pop it into the calculator. So it's going to be 0.9 minus root 19. I've got the root. Divided by 10 over 0.6 minus 0.9. There you go. That gives me as gradient is minus 1.547. Okay, which is about minus 1.5. Okay. You don't need to be too accurate. You just need to know how to do it, because if you had a question like this in the exam, they would give you a nice curve already drawn for you. So don't really worry too much if your answers are not exactly the same as in the back of the book. There you go.